Welcome to the 8th video on probability. We're going to talk about sample space, tree diagrams, determining the probability of an event and the complement of an event. We're going to take a lot of time to talk about the notation involved in these. I showed you these graphics here on this first page. These are different words. I mean, we use probability words all the time. It's quite likely, it's definitely, there's a good chance. It's unlikely, I doubt, there's very little chance. All of those are probability words. A sample space is the set of all possible outcomes for an activity or experiment. It is where you begin. You have to know what the possibilities, every possibility is, before you can determine probability. So for instance, rolling a die is singular, dice is plural. So rolling a die would yield a sample space of 6 possibilities. So that looks like set notation, 1, 2, 3, 4, 5, 6, just like that. Tossing a coin yields 2 possibilities. You get heads or you get tails, right? 1 coin. And then drawing a card from a standard deck of cards, we know that cards have 4 suits, and each suit has 13 cards. So that's going to give you 52 cards in a deck as a sample space. Now, if you wanted to know face cards or fours or cards that have aces low, then you would take that as a subset of your sample space. So here are some other sample spaces. If you had red and blue marbles in a bottle, right? I have 1, 2, 3, 4, 5 blue marbles and 3 red marbles. And so there's 8 total marbles in the sample space. And then these are all the possible combinations. You could have blue, 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 red. Anyway, you could have all the different colors written there. In rolling a pair of dice, these are the 36 outcomes that you could have, right? And we actually know this because you would have 6 outcomes for this, and the second dice also has 6 outcomes. 6 times 6 is 36. That would be your sample space. And then choosing an outfit from a green, red, black, sneakers, and sandals. There's 4 outfit combinations, and then you can just write those out and show which ones those are. So those are the 4 possibilities. Some people find tree diagrams when you're listing out the sample space to be to make things a little easier. For instance, if you needed the sample space for tossing 1 penny and rolling 1 dice, right, then you would have 1 penny would be heads or tails, and you can see that right here, heads or tails. So heads, 1 out of 2 possibilities, tails, 1 out of 2 possibilities. And then for each head, you would have 6 possibilities for the dice. And so here is your sample space: heads with a 1, heads with a 2, heads with a 3, etc. Tails with a 1, tails with a 2, tails with a 3, etc. And so the possibility would be 2 times 6, which is 12. So the possibility of any one of these outcomes would be 1 out of 12 of the outcomes. The outcomes for just tossing a penny, heads would be 1 out of 2 possibilities, and tails would be 1 out of 2. And then any coin would be 1 out of 6. I mean, not coin, out of the dice would be 1 out of 6. So you can kind of see how you would do a tree diagram. So our ratio for probability could be thought of just like this. It says the probability of an event, the probability of event is equal to the number of times the event can occur over or divided by the total number of possible outcomes. Now, the total number of possible outcomes is the sample space. So the notation for this looks like this. The probability of an event occurring is equal to the number of times that event could occur out of the entire sample space. So this part down here is called the sample space. So the probability of the event is the event number of events over the sample space. And then this chart shows that if the probability is 1, then it's certain that it will happen. And if it's impossible to happen, it will be 0. And then everything else is equally, is on a continuum from 0 to 1. Unlikely, equally likely is unlikely, 50% chance, 75% chance. And so, if you're ever asked, it's like zero possibility. It cannot happen. There is no way it could happen. Then your probability would be 0. Okay, so two coins are tossed. What is the probability that both will land heads up? So the first thing you do on any one of these is you determine its sample space. The sample space, all right? So I have 2 coins, and the possibilities for the sample space are that they would be 2 heads. They might be heads, tails. They might be tails, heads, or they might be tails, tails. And so that's going to give me the number of the sample space would be 4. Okay? And it says the event is what is the probability that they will both be heads. So that could only occur one time. So the probability of the event is going to be 1 time out of 4, and that's its probability. And remember that was the number of the times the event could occur over the sample space. And there's the whole notation. The second example says that a card is drawn from a standard deck of playing cards. What is the probability that it is a 4? So the first thing you determine is your sample space, and the sample space is 52 cards. Okay, 52 cards. And then what is the probability that it is a 4? So there are 4 4s because there are 4 suits in a deck. So the event, the number of the event is 4. The number of the sample space is 52. So the probability that I would draw a 4 is going to be 4 out of 52, which reduces to 1 out of 13. And so that's the probability. 2 6-sided dice are tossed. What is the probability that a total of 7 is rolled? Okay, so the first thing you do, of course, is find the sample space. And I have 2 dice with 6 possibilities on each dice, and that's going to equal a sample space of 36. The probability that a total of 7, okay, means that I need to look at all the possibilities. So I say 1 and 6, 2 and 5, and 3 and 4 are the possibilities. But also, since there's 2 dice, then I could say 4 and 3, 5 and 2, and 6 and 1. So the number of the event is going to be 6. So the probability of this event occurring, and sometimes when they put the event here, they'll actually say the probability of 2 6-sided, the probability of a total of 7. They'll write all those words in there. So that's going to be, there's 6 possibilities out of 36, so the probability is 1/6. The complement of an event is the collection of all outcomes in the sample space that are not in the event A. So if A is an event, then A prime consists of all the outcomes that are not that event. So here's some more notation. P of A, the probability of A, is the probability that A will occur given that A is in the sample space. P of A prime is the probability that A will not occur. Okay, so the probability, the complement, this is the complement right here, is going to be equal to 1 minus the probability that the event will occur, which kind of makes sense. So, for example, if the event occurring is 0.258, which a probability can be a fraction, it can be a decimal, it can be a whole number, and so it'll be somewhere between 0 and 1, so it could be a decimal. Then what is the complement? Well, I would do 1 minus P of A, which is 1 minus 0.258, and on the calculator that would come out to be 0.742, so therefore it would be more unlikely that it would not happen, or the complement of it would happen, than the actual event. So the next problem would be a sample of 60 people with different blood types. 18 had O, 32 had A, 7 had B, and 3 had AB. And if a person is selected at random, find the probability that the person A has type B blood. So the first thing you need to know is, of course, you guessed it, sample space. So the sample space is going to be 60, right? And the other notation for that is N of S is the number in the sample space. All right, type B blood, there are 7 of the 60 people who have type B blood, so the probability that someone has type B blood would be 7 people out of 60, and that does not reduce. All right, if a person had B or AB, you could write it like this. The probability that they have B or AB blood, right? You could write words there instead of the event. All right, so then how many people have type B blood? That would be 7. And how many people have type AB blood? That would be 3 out of how many? 60. So 10 out of 60 would just be 1/6. So that's the probability. If they do not have A blood, then that means 2 things. It means they have either O, B, or AB. So you could take those 3 things and add them up. Or you could just find type A blood and subtract that probability from 1 and get the same thing. So the probability of not A would be 1 minus, well, how many people have A blood? 32. So 32 of 60. And then that would equal 28 over 60, which reduces down to 7 over 15. So the other way you could do that is you could say not A equals over 60. Not A would be 7 plus 3 plus 18, which is still 28 over 60, which still reduces. So either way you can do it. D says has neither AB nor type O blood. So you could do the same thing there. You could say this is actually asking how many people have B or A. Do you agree? So the probability of somebody who has B or A blood would be out of 60. B is 7. A is 32. So that would be 39 over 60, which reduces down to 13 over 20. And you would want to reduce that fraction every time. Here are the 3 problems that I would like for you to work for homework. Using a standard deck of cards and drawing 1 card, find the probability that it's black, a king, or an 8 of spades. All right, so I will see you in class with these answers ready to go. And I hope you're enjoying this. These are really kind of different. This discrete math and combinatorics is a lot different than what we've been doing in the past with algebraic abstractions and graphing. So anyway, I'll see you in class.